And let's begin with the two concepts about the angle of the elevation and angle of depression. So when you have the point at here, say let me call this point P. So this point P, which is above the horizontal line, then you are here. This is the position of the observer. So now, the angle of the elevation for this point P is the angle formed by this horizontal line and the line of the sight through this point P. So this angle alpha is called the angle of elevation. Now suppose you stand at the top of a building and you have one point P which is below this horizontal line. Then in this case you may define the angle of depression. The angle of the depression is angle formed by this horizontal line and the side and the line of the sight through this point P. So that is this angle beta. Now, with these two concepts, let's look at some application problems. And let's first go to the page 497. Let's look at the problem 42. It's about the giant redwood. It says a hiker stands 80 feet from a giant redwood tree and sights the top with an angle of the elevation of the 75 degrees. Then how tall is this tree to the nearest foot? So we need to find the height of this tree. Let's go back to the whiteboard. So this is the page 497, problem 42. And let's first draw a sketch. It says a hiker is 80 feet away from a tree. And when the hiker sights the top of the tree, the angle of the elevation is the 75 degrees. So this one is the 80 feet, right? And then we need to find the height of this tree. That is this length. Okay? So now, tell me which function should I use? Which one? To determine this h, which function? Tangent, right? Tangent is equal to opposite over the adjacent. Here you cannot use the sine or the cosine because the length of this hypotenuse is unknown. We just know the length of this adjacent side. So you may use the tangent 75 degrees, which is equal to opposite h over this adjacent 80. Then you multiply both sides by 80 degrees, or by the 80, then you have the h is equal to 80 times the tangent of the 75 degrees. And then you use a calculator. You have the 298.56 feet. And this is the height of this giant redwood. Okay? Any question? Now, let's look at one more exercise. Let's look at the 46 on the same page. And in this problem, we have a tunnel. A tunnel on a river is 196.8 feet below the surface at its lowest point. So this noise point, and this length is the 196.8 feet. As shown in this drawing, if the angle of the depression of the tunnel is the 4.962 degrees, so this is angle of depression, then how far apart on the surface are the entrances to the tunnel? So we need to find the distance between these two entrances, okay, to find this D. So first, we can draw a perpendicular from this point to this side, and then we can form a right triangle. So this is 90 degrees, and the sky is the 4.926 degree, and we know this length 196.8 feet. So now we need to find the length of this side and double this length, then we get the distance between the two entrances to this tunnel. Let me draw this sketch on the whiteboard. So 46. So let's first sketch this right triangle. And the length of this neck is the 196.8, and this length is the half distance between the two entrances, and this angle is equal to 4.962 degrees. So first, we have the tangent of this angle 4.962 degrees equal to the opposite over the adjacent. So that is the 196.8 divided by d over 2. Now we multiply both sides by this d over 2, then we get d over 2 times the tangent of 4.962 degrees equal to 196.8. Then we divide both sides by this tangent of the 4.962 degrees. Then we get d over 2 equal to 196.8 over the tangent of 4.962 degrees. Then we multiply both sides by 2. We get d equal to 2 times 196.8 over the tangent of the 4.962 degrees. And use the calculate to compute. Then you find the distance, which is 4533.50 feet approximately.